Good morning students. In the previous video I told you how to get the inverse of a matrix, okay, using determinants. That was what, that if A is any matrix, square matrix, A inverse. How you get A inverse? You get, formula was adjoint A by determinant A, where determinant A should not be equal to 0. That was, and very important property I told you. Adjoint A, I told you how to calculate. You might have done practice of getting A inverse. Now one important property was there. I told you that A dot adjoint A is equal to adjoint A dot A is equal to determinant A I. Okay, so what actually I am saying, this is also so many times one mark question comes on the basis of this, so I am explaining this. A dot adjoint A is equal to determinant A I means what, that actually it's a matrix and it's a constant. Determinant A means what, it's a number. So I is a identity matrix. Suppose I is an identity matrix of order 3, I3. So I am going to multiply this 0, 0, this is 0, determinant A. With each element it is multiplied. So 0, that is 0, 0, determinant A. This is a matrix actually. This is a matrix A adjoint A. Now how to get the determinant of adjoint A? So I am taking determinant both the sides. So taking determinant both the side means A dot adjoint A. This is determinant of this one and determinant that side also. Taking matrix determinant you are going to take means what, that you are taking this A 0, 0, 0, determinant, this 0, 0, 0, determinant A, determinant. So you will be saying determinant means this is common from this row, this is common from this row, this is common from this row. And in determinant we are going to take common from each row. So it will be what, your A cube. And what will be determinant of I? Determinant of I, if you are going to calculate it, is what, your determinant of I is always comes 1. You can calculate it, so it will be what, your 1. So now determinant of A, B we have studied, that is determinant of A, determinant of adjoint A. Determinant of AB using what? Determinant of AB is the determinant of their product. Okay, so determinant of A, determinant of adjoint equal to what? Determinant A cube. So when you are going to divide it, it will be coming determinant of adjoint A. Determinant of adjoint A is equal to what? A square. Means this question comes, determinant of adjoint A is equal to determinant of A power less than, power is lesser by 1. Lesser by 1 means if A is a matrix of order n, then determinant of adjoint A will be equal to determinant of order n minus 1. Okay, so when sometimes they give you the value of determinant A, suppose it is given yours 5, okay, and order of A is given what, that it's given, for example I am saying determinant A's value is given 5 and A is a matrix of order 3 cross 3, and they ask you the question, find out the determinant of adjoint A directly. So it will be what, your 5, 3 minus 1. So it will be what, your 5 square. So it is 25 years our answer. Okay, so 1 mark question directly comes, what is the value of determinant of adjoint A? It's determinant A n minus 1. N is the order of the matrix. Okay, you can solve 1 mark question based on this one. Now another type of question I am telling you. For example, one question is given in your NCERT also, that is question number 15. It is said that if a matrix A is given, yours what, 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. This is a matrix given. Okay, and they are saying show that A cube minus 6A square plus 5A plus 11I is equal to a null matrix. And second part is hence find A inverse. Hence find A inverse. Okay, first to this part you all know how to prove it equal to null matrix. A cube means you are going to first A dot A square, then A square dot A cube will come. So you are going to get all the part, then add whatever it is, it will be coming in. Hence find A inverse means using this find A inverse. For that what we do always, we take identity matrix another side. So you will be getting what, that your A cube minus 6A square plus 5A is equal to null matrix minus 11I means it will come minus 11I. Okay, now what I am going to do, I am going to pre-multiplying by A inverse. What that you are pre-multiplying by A inverse means both the side. First I am multiplying A inverse, so it will be your A inverse A cube minus 6A square plus 5A is equal to what is your minus, scalar will be out, A inverse I. A inverse I, so you are going to now multiply. So you will A inverse A square, you are going to write this one, minus 6 A inverse A, and A square will be splitted A, plus what is your 5 A inverse A is equal to what your minus 11 A inverse I, identity matrix multiplied by any matrix. A inverse is a matrix, any matrix, it will give you A inverse, correct or not? So A inverse A, you know what it is, nothing else but I is your identity matrix, A square minus again this is IA plus what is your here 5I is equal to minus 11 A inverse, correct or not? So you are going now, expression is what it is coming actually, this expression is coming yours IA square minus IA plus 5I is equal to minus 11 A inverse. So now it will be your minus 11 A inverse, IA square will be A square only minus A plus 5I. Now you are going to put A square, you might have calculated before only, A's value and this one, and then you divide by minus 1 by 11. One matrix will be coming here, what is, that is your answer. Okay, how to get A inverse when a matrix is given, you can get this one different kind of question will come on the basis of this. Now I am going to take what is the application of this A inverse. Application of A inverse to solve system of linear equation. System of linear equations. Okay, so what that if it is given yours, what that a1x plus b1y plus c1z is equal d1, your another equation is given a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z equal d3. Okay, use inverse of matrix using determinant to solve the system of linear equation. That comes 6 mark question. Okay, so listen how we are going to solve it. Listen carefully. I will be dividing into matrix. How I am dividing? I am taking A matrix is how coefficient of x a1, this coefficient of y b1 c1, then a2 b2 c2, and then what is your a3 b3 c3, this is matrix A. Then I will say x, what it is yours, x will be your x y z matrix, and what is your, suppose any other matrix yours, you say B matrix, it is what your d1 d2 d3. So if I write ax is equal b, so you see ax equal b, if I am multiplying this and equating this one, what is this one? It is your 3 cross 3, and this is what yours 3 cross 1 order. So you are going to get 3 cross 1, this a1 with this one, and equate d1. You are going to get back again your equations. Understanding or not? This row with the column you are multiplying, equating with d1 first equation, row with the column equating this d2 second equation, row with the column equating this d3 third equation. So I can write in matrix manner this equation in matrix manner, how ax equal b. Okay, so now you are, what is the question? You need to find out the value of x, y, z. So you need to know the matrix x. Matrix x, for this I will be pre-multiplying with what? With A inverse both the side, with A inverse both sides. Okay, so what I will be doing, A inverse ax is equal to A inverse b. A inverse A is nothing else but a identity matrix, x is equal to A inverse b, and identity matrix multiply with any matrix will give you same x. So x is what your A inverse b, x is what yours A inverse b. Now you got x, y, z. So this will come your x, y, z, and this will come one matrix which is equal to some value 12, 13 like that. So x equal 12, y equal this. With the question you will be getting it 12. So means what x you are getting your A inverse value, you know, adjoint A by determinant A b. Okay, and determinant A should not be equal to 0. A inverse how you are going to get? Adjoint A you are going to calculate by determinant A. This is A inverse. then A inverse will be multiplied with B, and then equate with X. You are going to get the value of X, Y, Z. Now determinant A should not be equal to 0. So when determinant A is not equal to 0, system is consistent. What is called it? System is consistent. And we say unique solution exists. Unique solution exists. Okay. And second case is if determinant A equals 0, it's a singular matrix. Okay. Then you are going to calculate what? Adjoint A, B. This value you are going to calculate. If it is not equal to 0, it is not equal to null matrix. Okay. Then no solution exists. 1 mark question asks on the basis of this one. No solution exists and system is inconsistent. System is inconsistent. Okay. And this is again if A equal to 0, but your adjoint A, B is also null matrix, equal to null matrix. Okay. Then you will say system may be consistent or not. Infinite many solution exist. What is that? Your infinite many solution exist. And system is dependent. System is what? Your system is consistent and dependent. Consistent and dependent. Okay. So what that? How we are going to utilize actually? Generally, question comes about that when it's what your non-singular matrix. Generally, question comes this generally only for your theoretical knowledge. 1 mark question may be asked on the basis of this one. Actually comes when first you calculate this determinant A should not be equal to 0. Then you are going to get A inverse by what? Adjoint A by determinant A. Then you are going to multiply with B, and you are going to get your what? Variables value X, Y, Z on this one. Okay. You might have understood the basic of this one. Now you need to practice the questions. Some I will be sending you. Thank you, students.